This is the software which we have. This is a RoboAnalyser icon which you can see here. When you click that, okay, you'll get a screen. Okay, so this is where you have to visualize. So first thing you have to see what are the DH parameters in this table. So you have two joints. So in the default, uh, as default, by default, you get this 2DOF revolute joint robot. Okay. So as you can see here, since it has two joints, you have two, number one and number two, both joints are revolute joint. Okay, so this is joint offset. Now the joint offset is 0, which is given in meters. சரியா? Next one, the joint angle theta degrees, which is variable. Why it is variable? Because this can be rotated. Okay, so this, since it is a revolute joint, it gives rotational motion and hence it is variable. Okay, how much it should vary, that can be given in this. Okay, final value from 0 to initial value from 0 to final value to 180 degrees. Okay, so this second revolute joint should has a joint offset of 0. Joint angle is variable. It is varying from initial value of 0 to final value of 90 degrees. Okay, so link length, so the length of the link, how much it how much the length of the link is, and then the twist angle. So compared to the second joint, what is the twist of the first joint? Okay, compared to the third joint, what is the twist of the what is the twist of the second joint? Okay, so this is what you should mention in this table. So as you can see, joint offset. So joint offset, when I change here, okay, 0.5. You can see here from the base there is some height. Okay, after some height, a height of about 0.5 meters, a link is connected. Okay, so in case of a revolute joint, this is the joint offset. So if you observe the trajectory, you can see, okay, the first revolute joint will be rotating about 180 degrees and the second revolute joint will be rotating about 90 degrees. When this is the case, you get this as the trajectory. So what is the trajectory you just observed? C is the trajectory. Okay, so if you change to 0.2, you get a reduced height according to what value you are giving. Okay, so if you change this joint offset, so joint offset is equal to 0.2. Okay, you can see here. So with respect to this link is connected at a height of 0.2 meters. So this is what joint offset is. So what work volume you need, okay, depending on what work volume you need, you can select the joint offset. Okay, so this is a kind of a spray gun. You can place a motor here, you can rotate this joint, and if you have to spray something over here, you can connect a spray gun to it, so that you can spray at a height of 0.5 meters. Assume there is an application like you have to constantly spray at a height of 0.5 meters, okay, or 0.4 meters. Okay, so this can be the configuration. Okay, so constant you have to apply a paint. So that kind of application you can use this. Otherwise, if you have to use a 6 degree of freedom robot, that can be used to paint like 0.5 meters, 1 meter, 3 meters, என்ன ஹைட்னாலும் நீ வந்து பெயிண்ட் பண்ணிக்கலாம். ஓகே. ஸோ உன்னோட அப்ளிகேஷனை பொறுத்து நம்ம அப்ளிகேஷன் வந்து 0.5 மீட்டர்ஸில் தான் உனக்கு வந்து கான்ஸ்டண்ட்டாக யூ ஹாவ் டு பெயிண்ட் அப்படின்னா கேன் யூஸ் திஸ் கான்ஃபிகரேஷன். ரொம்ப ஈஸியாக முடியும். ஓகே. So link length, you can see here link length. So this is a joint. So this bar is completely a joint. This bar is completely another joint. So in the joint, how we are connecting using this link. Okay. So this is link number 1. Okay. So this is link number 2. Okay. So when we change this 0.3, you can see there is a difference in the link length. So this, if you change this to 0.3, you can see sometimes the enter won't work. At that case you have to press F key. Okay, you can see increase in the length. Okay, this is what I am trying to visualize. Okay, so the next thing is twist angle. So as I said, twist angle is the amount of angle angle twisted for the second joint with respect to the first joint. Okay, so if you change to 45 degrees, small angle will be twisted. You can see a twist of about 45 degrees. Okay, so minus 45 degrees you can see the direction changes. Okay, so minus is for counterclockwise, plus is for clockwise direction. Okay, so even though you twist by an angle of minus 45 degrees for the second joint, there will be no difference as there is no third joint connected to it. Okay, so this doesn't provide any meaning. Okay, so this, sorry, you get a positive for counterclockwise direction and negative for clockwise direction. Okay, so please note it. Okay, when you provide an angle of 0, so there is no twist of the second joint with respect to the first joint. If you provide an angle of 90 degree, then you can see the second joint is at an angle of 90 degree with respect to the first joint. So this is twist angle with respect to a revolute joint. Okay, so this axis blue color, this red color and this green color axis represent particular axis. So blue represents Z axis. You can see here when you run it. So there is a motion. So you can see here along Z axis movement. Okay, so that is observed by movement along blue axis. Okay, so this we will be seeing in detail in the next classes, but these, I just wanted to say these 3 colors means 3 individual axes. Okay, so depending on what configuration, what application and what is the trajectory you need, you can select a particular configuration robot. Okay, so this, even though I change to 90 degree, will not be able to visualize anything, but if you change this, okay, now the twist angle is 0, link length I am changing back to 0.1, so this is 0.1 again. So this is joint offset. Joint offset I am changing to 0, and then this is joint offset, again changing to 0. Okay, so you get a pure 2DOF revolute joint robot. Okay, so this is for revolute joint. Now I can understand that you would have learned this concept. So next one, we go for 1 degree of freedom revolute joint. Okay, so this is 1 degree of freedom revolute joint. There is only one joint and one link. Okay, so if you change this joint offset is changed to 0.2. You can see here an increase in this length. This is along Z axis. So if you change the joint offset, you get an increase in the length along Z axis. Okay, so this is link length. If you change to 0.25, you will get okay, so you will get an increase in the length. Okay, then twist angle, so I change to minus 90 degree. So even though I change it, so there will be no change. You cannot visualize this structure of the robot since there is no joint connected. Okay, so initial value and final value minus 90 degree to plus 90 degree. So if we change to 0 to some around 45 degrees, so it will rotate up to 45 degrees. Okay, so it rotated up to 45 degrees. So if I change to 90 degrees, so it will rotate somewhere around 90 degrees. Okay, so this is what the 4 DH parameters of a revolute industrial robot. Okay, so a robot which has all the revolute joints as revolute. Okay, so now when I change to DOF prismatic, so you can see here, so both the joints are prismatic. So the link I'm changing here to 0.1 so that you can visualize. Okay, so this is a revolute joint, so sorry, prismatic joint. So you can see here, this is the joint, and over this pink color metal bar will be moving. Okay, so this is a link. Okay, so this is another joint which moves over this thing. Okay, so this is the second link. Okay, so this yellow color is the second link. So when I run this, you can see here. Okay, so this joint moves over this ash color thing. This is a link, so this yellow has moved over this metal bar. Okay, so since it is moving and parallelly this yellow is moving on this purple color bar, you get a slanting line. You can see here the trajectory. You are getting a slanting increase in the line. Okay, increase of height in the line. Seriya? Okay, so now in case of a prismatic joint, what is a joint offset? So prismatic joint, what is a joint offset? So if you have to click a view, so you can press this, so you'll get an isometric. Okay, so if I am first thing I am changing this joint angle. Why? Because in case of a prismatic joint, this joint offset is variable. Okay, so in revolute joint, this joint angle was varying. In joint offset, you should note that. Uh, Sorry, in case of a prismatic joint, you should note that joint offset is varying. Okay, so joint angle we can fix a particular degrees of angle. Okay, so when you place this as 45 degrees, you can see here, so it is being rotated. Okay, so you can see here the second joint is connected at 45 degrees to the first joint. Okay, so when we keep this as 90 degrees, you can see here it is perpendicular, correct? Okay, so it is perpendicular, you can see here. Okay, when I change this to 45 degrees, there's a small change in angle. Okay, so when I change the second joint angle, you cannot visualize because there is no third joint connected. Okay, sorry. Okay, sorry, there is a link connected. Okay, so there is a link connected, so the second link obviously will get changed. Yeah. Okay, so when I change this to 90 degrees, you will get a change of minus 90 degrees counterclockwise. So when I change to minus 90, you will get a change in clockwise direction. So again, this is the link length. So when I change this, you can see an increase in the length. Okay, so this is also, you can change this. Okay, so twist angle, again, how much it is twisted, the second joint with respect to the first joint, how much it is twisted. Okay, so you can see here it is twisted at an angle of 45 degrees. So when I change this, twist angle, okay, so depending on what trajectory you need, you should select these parameters. Okay, so again, finally, this initial value and final value. So the joint offset, which means the length of this metal bar, okay, over which this prismatic joint moves. So this we can, if we have to move only up to 0.2, obviously the length of the metal bar changes. Okay, so when it is 0.1, so I can see the length of the metal bar is reduced. Okay, so finally this final value, okay, so this is in case of a prismatic joint. So there is slight difference of DH parameters in case of a prismatic joint and a revolute joint. In a revolute joint, joint angle will vary. In case of a prismatic joint, joint offset will be variable. Okay. Okay. Then, in a case of one DOF prismatic joint, you can see here. So there is only one. What is this thing? This is joint offset. So this is a link. Okay. So joint angle. Okay, the angle at which the link is connected. Joint twist angle is the twist of the second joint. Okay. So you can see here joint angle, and we change this to 45 degrees. Okay. So it has twisted. So it has changed to 45 degrees. Okay. So this is joint angle. So link length. So the length of the link. Okay. So the twist angle. So twist angle. The angle, the second joint is twisted. So this you cannot visualize. You should have a second joint. So initial value, the moment of the prismatic joint from 0 to point 0.1.2. So when you run this, you will get a corresponding trajectory. Okay. Okay. You can again see here 6 degrees of freedom revolute joint. Okay. So this is 6R joint. Okay. So you have 6 revolute joints, 6 joint offsets, joint angle which can vary, twist angle, and then link length. Okay. So individually you can set the parameters and you can see how you are getting the trajectory. Okay. Is this clear? So is this clear?